Sometimes when working with equations, we run into ones that are called quadratic in form. This is because if we do a little algebra manipulation and some substitution, we can get the equation into the proper quadratic form. Sometimes these kinds of equations have negative exponents or even have fractional exponents. So let's look and see how we would approach each one. First one we have is 10z to the negative 2 plus 11z to the negative 1 equals 6. So it's not quite in the quadratic form we need. We need to be set equal to 0. So we're going to first subtract 6 from both sides to do that. So we're going to get 10z to the negative 2 plus 11z to the negative 1 minus 6 equals 0. And just like before with substitution, we're going to just see what we need, which is typically just the middle variable. And we're going to let that equal u, like so. Once we have that, we're just going to go over and substitute it in. So 10, and there's 2z to the negative, 2 of these here, 2z to the negative 1s. So we say this is just u squared. Plus 11, and there's 1z to the negative 1 here, so we just say u minus 6 equals 0. And now again we can solve quadratic, complete and square, factoring, whichever you prefer. I'm going to do factoring because I think that's easier, and I'll skip a few steps and just go straight to the answer. But when you factor this down, you should get 5u minus 2, and you should get 2u plus 3. And then we'll set each one of these equal to 0. 2u plus 3 equals 0. And we'll solve. Add 2, divide by 5 is going to give me u equaling 2/5. And then subtract 3, divide by 2. U is going to give me negative 3/2. So again, I know what u is, but in my original I had z's. So I need to find out what z is. So that's what I'm going to do. I'm going to go over here and replace it. So 2 over 5 equals z to the negative 1, and negative 3 over 2 equals z to the negative 1. So what do? Well, can't do much with a negative exponent. I don't like it. So what I'm going to do is I'm going to bring it into the denominator and make it positive. So 2 over 5 equals 1 over z. And now I'm going to do cross multiplication. Multiply z up here, multiply 5 over here, and I'm going to get 2z equals 5. And then divide by 2, z equals 5/2. So there's my first answer. And we can see, honestly, all we did was just take our answer we got for u and just reciprocate it, which is going to be the same thing here. But I'm going to go through the steps anyway just to show it. Again, I don't like the negative 1, so I'll bring it down and make it a positive 1. So negative 3 over 2 equals 1 over z. Multiply z over, multiply 2 over. Negative 3z equals 2. Then divide by negative 3. Z equals negative 2 over 3. Again, the same number, we just flipped it. Next we have x to the 2/3 plus 3x to the 1/3 minus 4 equals 0. In quadratic form, so I'm happy. So I can immediately go to my substitution. So u is going to equal, again, the middle, which is going to be x to the 1/3. And now I'm going to just plug it in. So there are 2 1/3s here, so I can say this is just u squared. There's 1 1/3 here, so I can just say it's 1 minus 4 equals 0. And again, I'm going to factor it, or quadratic, whichever you prefer. And I'm going to get u plus 4 and u minus 1. So set each one equal to 0. And I'm going to get u equaling negative 4 and u equaling positive 1. Now again, I have x's up here, not u's, so plug it back in here to figure out what x is. So negative 4 is going to equal x to the 1/3, and 1 is going to equal x to the 1/3. Now I got to get rid of this 1/3. So what I'm going to do is I'm going to cube the whole thing. But what I do to one side, I must do to the other. So that's what I'm going to do. So -4 cubed is -64. And then 1/3 and 3 is just going to cancel out and give me just a plain x. So here's the first solution. And if I did it before in the other one, that means I'm going to do it here to this one as well. So cube both sides. 1 cubed is 1. And then 1/3 and 3 cancel out, leaving you just an x. And there's little that can be done because we're done. My solutions would be 1 and -64.